the first day of the environmental stuff by talking about heat balance. And so a lot of this kind of focuses on hot environments, but it's also just as important with cold environments. Basically, any environment that has temperature, this is important, which is every environment, right? So here are the objectives or outcomes for this lecture. So the big thing that we're going to be talking about are the different ways of heat transfer. We mentioned this, or I mentioned this in one of the first lectures of this week, where we're talking about conduction, convection, evaporation, radiation. Okay? And so when you think about temperature, ultimately what it is a function of how much are you gaining, how much are you losing. So when it comes to heat gain, metabolism will always increase core temperature, right? Chemical reactions give off heat. Much of this heat is just lost. And what I mean by that, it generates heat, or much of this energy that's released is released as heat, and then we're unable to convert that into work. Then on the other side, there's heat loss. Evaporation will always cool you off. Okay, there's no way that we are aware of that evaporation will cause an increase in core temperature. And then you've got radiation, conduction, and convection. And depending on the gradients and the direction of the gradient, that can result in core temperature increasing or decreasing. I forgot to take this off because we're not in person anymore. But I want you to think for a minute, what do we mean by metabolism, radiation, conduction, convection, and evaporation? And if there's someone in the room with you, you can share this with them. All right, so metabolism is just the energy that's released when we break down like ATP. Now, what's really interesting is that only about 25% of the energy that's released is converted to work. Everything else is released as heat, okay? It's relatively inefficient, all right? This is true of like a car engine, right? This is why car engines get hot when you drive them for a long time, is that it's generating heat when energy is released. Okay, some of that energy that's released goes to propel the car forward or whatever, but a lot of it is lost as heat. Then we've got radiation. And so with the rest of these, except for evaporation, this is heat. We're talking about heat transfer. Okay, so radiation is where heat is being transferred via electromagnetic waves. Okay, so usually what happens in the environment is that the electromagnetic waves that are in the atmosphere, we absorb we give off electromagnetic waves, or we give off heat because generally our core temperature is higher than the atmosphere, right? It's like 70 degrees today. Your core temperature is 98.6. We always go down the gradient. So we're going to give off heat via radiation. Then we've got conduction. And so this occurs when two objects touch each other. So if you touch like the counter, so my table right now, my desk is actually cool. And so what's happening is temperature or heat is being transferred from my fingertips into my desk. That's why it feels cold. I'm losing heat. Whereas if I touch, when I'm using my smoker later this week, if I touch it, what happens is it feels hot because I'm actually absorbing, or that heat's being transferred from my smoker into my poor fingertips that are now burning. Then we've got convection. And so convection is a heat transfer as things move through a fluid. The more movement you have, the more fluid movement, the more heat transfer you have. Now, air is a fluid, and so convection does occur, but air doesn't really have high convective properties. Water, on the other hand, does. Okay? Water is very good at giving off or absorbing heat. All right? And if you don't believe me, or an easy way to realize this is if I were to tell you, hey, I want you to put your arm in an oven that's 350 degrees as you pull out the cookies, okay, you could actually keep your hand in there for a few seconds before it becomes uncomfortable, but you're actually not going to hurt yourself. There's not going to be any damage, even though that temperature is really hot. Whereas if I tell you, or have you, I would never have you, but if you were to have an unfortunate accident where you put your hand in boiling water, which is only 212 degrees Fahrenheit, like that's going to be a big issue. You're going to get scald, you're going to have those scald burns. And that's because heat transfers a lot more efficiently from water, or from water, than it does from air. And then finally, we have evaporation. And so this is where we convert a fluid into a gas. So in this case, water, the liquid form of water is converted to the gaseous form of water. And when this happens, heat is lost. And so evaporation only causes heat loss, and it's the most effective way at losing heat. All right. But in order for sweat to be effective, it has to evaporate. So when you wipe it off because it doesn't feel great, you're actually getting rid of you're preventing evaporation from occurring. So let's just think about this for a second. So let's say that we go for a 30-minute run, clear, sunny day. It's 40 degrees Celsius, 104 degrees outside. So what's going to be going on with heat transfer? Okay. And so the answer is this. I'm going to gain heat from metabolism. I'm going to gain heat from radiation because the atmosphere is hotter than my body. I'm also going to be gaining it from conduction. There's going to be very little, but there'll be some because I'm touching the ground. Okay, and odds are if I'm running when it's 40 degrees outside, that the ground, especially if I'm running on asphalt, will be much hotter than that because it holds on to that heat. And then convection, the air is 40 degrees Celsius. My body's only 37. Okay, I'm going to gain a little bit of heat just through the act of convection. However, if evaporation is occurring, I'm going to lose heat through evaporation. Now, when it comes to cooling, the only way that we can cool a body if it's hotter outside than it is in our body is through evaporation. Okay, so when it's above 98.6 degrees, give or take, the only way we can cool off is evaporation. But the only way that evaporation occurs is if the atmosphere has the ability to hold water. And so this is why relative humidity is very important in determining how much evaporation occurs. Okay, I mentioned, I think in the first video, that I would much rather spend summers in Phoenix than I would in Indiana. Even though it's 20 degrees hotter in Phoenix in the summer, give or take, it's a lot drier. And so it's actually, you could make an argument it's easier to stay cool because when I sweat, that sweat immediately evaporates and cools me off. Whereas here, when I sweat, all that happens is I get gross and I just feel all wet, okay, because the sweat's not evaporating as quickly because the atmosphere has so much water in it. Okay, so as relative humidity goes up, evaporative cooling goes down. Okay, and just to reiterate, sweat doesn't cool the body, it's the evaporation of sweat. When it comes to regulation of temperature, remember normal temperature that we at least stay is 37 degrees Celsius, which is 98.6 Fahrenheit. Generally, as long as we're between 35 and really 41 Celsius, so that's 96 Fahrenheit to about 105 Fahrenheit, we're good. Now, it is possible, and at times, exercise can cause your core temperature to actually exceed that. Assuming everything's working okay, as long as you cool off, life's good. But we really try and stay between 35 and 40 and 41 for things to work properly. Okay, but as you can see here, really 35.6 to 38 is kind of right where we want to stay. If we get out of that range, then we start to have adjustments made. Okay, so when it comes to temperature regulation, this is governed by your hypothalamus. It's the thermostat of your body. And so we regulate it within a narrow range. And really, all that it takes is about a change of 1 to 2/10 of a degree Celsius for you to either start sweating or shivering. Okay. Now, the hypothalamus knows what's going on because there are thermoreceptors all throughout your body, including in your brain, as well as in your skin. And there are other places as well. Okay, but these send inputs or these send information to your hypothalamus, and then your hypothalamus makes a decision. I need to sweat, I need to shiver, or I just need to do nothing. Okay, so what happens though if a change needs to occur? Well, if it's hot, the arterioles that go to the skin are going to dilate so we can increase blood flow and lose heat. Remember, blood is a great, one of the things it transports is heat. And so when we get hot, we dilate our skin blood vessels, we lose heat. Okay. We'll also activate those sweat glands, and so sweat is released onto our skin. Hopefully that sweat evaporates and we decrease our core temperature. Conversely, when it's cold, our muscles will shiver, and these are those involuntary contractions. Remember, when we break down ATP, most of that or a lot of that's released as heat as opposed to usable energy. Okay, and so we shiver, generates heat, and we try and warm up. Okay, and there are some hormones, such as thyroid hormone, that will increase metabolic rate, which will increase the activity of metabolic reactions, which means more heat is released.